In this video, we're going to go through our next example, which involves a base jumper and also trying to transform the scales in order to get a lovely linear correlation. I would suggest pausing this video and making sure that you have all of the data that appears on the handout there into your CAS calculator or whatever other device you're using for your statistical analysis. I'm going to give you a moment to do that, and then once you've done that, come back and we'll continue. So right now you should have your statistics function filled to the brim with a brand new set of data where we've got a base jumper. Someone's jumping off some manner of cliff top there. There's our base jumper over there. And we're going to see how she falls off the cliff, preferably with some sort of parachute type thing, and to see what it looks like, and to also go ahead and plot. So we're wanting to see, more than likely, we're probably wanting to see, given a certain amount of time in seconds, or how long would it take until she gets to the ground, that sort of thing. So you want to make sure, may as well have a look, because the first thing it says to construct the scatterplot, displaying height as the response variable, it's RV, not talking about a motorhome here, or against time in EV. So making sure that our scatterplot is on list 1 and list 2, so we'll set that, and bang, there we go. Oh, look at that beautiful non-linear curve that we've got going on there. So what you would need to do is you would need to plot each of these particular things here. I am going to cheat because I am a dirty cheat, and I'm just going to screen capture this and plop it into my notes here. Of course, when we do a scatter plot, we need to make sure that everything is labeled accordingly. So we need to make sure that our axes are the correct labels, and we've also got a heading. So this is, I'll get a pen out here. So this response variable is the heights. So we'll put height, and it's been measured in meters. And down here, this is the time measured in seconds. Now we can give a title to this as well. This is the time taken, or we can say what can we say? The heights from, because where is the height? It's the height is from the ground, presumably. So the height from the ground of a base jumper in meters over time in seconds. There we go. Cool, so we've done this. We need to find a correlation coefficient. So we'll need to go and do our linear reg trick over here. So what I'm going to do, and I might get my old keyboard out here because we might need it at some point soon. We're going to go click on this graph. We're going to go calc. Yes, we're going to go to calc even. We're going to calc regression linear reg, list 1, list 2. Yep, that will do us nicely. So we press OK. There is the equation there, and we've got the correlation coefficient is R, and it's at negative 0.963. So negative 0.963. Now I have to tell you, that's a pretty good correlation coefficient. In other words, if I draw a straight line going through that, as we'll show up here, yeah, it's not too bad. We can see that it is a curve. So if I was just to copy residuals into list 3, just for the sake of it, it would also help. There it is. Now, if I plot the residuals for this one, this is not asking the question. I'm just saying that, all right, we've got a very good R value. But you might remember that I was saying that, you know, if we plot the residuals and if there's any sort of form of pattern, then it's definitely non-linear rather than linear. So I'm going to go to setting, list 1, list 3, set, and we'll have a look at that. And look at that, the residual plot is a pattern. So that means that even though this is a very good R value, it's quite clearly not a linear line. So there are two choices that we can make to linearize this data. So It says there. Now, just to remember where that came from, you might remember from earlier, that scatter plot is, so let's have a look at which ones it's looking like. So it's curving in this direction, so that would mean that it's our top right option. So there we can either square the y values or square the x values, or square the response variables or square the explanatory variables. So we're going to do exactly that. We're going to see which one will have the stronger association. So we're either going to do x and y squareds, or we're going to do x squareds and y. Remember, when we're doing transforming the data, you're only doing it to one variable. So our ordinary one is 0.963. What we're going to see is we're going to see if we can get a better r value from either of the other two as well. It might even be worthwhile, it's just as I'm thinking here, it might even be worthwhile to go and compare it with the actual residuals and see if they're still quite linear. So I can clear list 3. If you just want to get rid of a particular column, by the way, just go to calc, also go to edit and delete column, and that will just get rid of that. So what I'm going to do is I'm going to square the y value. So you might remember with this one here that what we do is we go and give this an instruction. So we're doing list 2 squared, which you'll notice it's come up with these sort of summarized numbers, 2e6. That little e is just times 10 to the power of, so that's saying 2 times 10 to the power of 6. That is because it can't actually physically fit that number in there, that's all. Although I believe you can actually make this a little bit wider. So yeah, so you can actually make it a little bit wider. And so if you just press those 3 columns there, you can actually make this a little bit wider. But yes, I'm just going to keep it a little bit narrower for now. So what I'm now going to do is I'm now going to square the x values, and I'll do that here. Again, list, in this case, list 1 squared. And I've got my squared values. What I'm going to do now is I'm going to go and put these values into the cas. Now, I know it says that I should have copied them out, but I'm not going to bother copying them out. I'm just leaving them in here. I don't think you need to watch a video of me copying answers in here. But what we're going to do is we're going to set the graphs, and we're going to have a look to see which one has the better r value. So we're going to, setting, going to go scatter. In this case, for the first one, where it's x and y squared. So the x list is still list 1, but for y squared, that was list 3. I better make sure I get these down, because I will forget. List 2, that's list 1. Set. And then I'm going to do a linear regression. List 1, list 3. And we've got negative 0.973, and we have an equation of the line here. So what we can do is we can go and write down that equation, lest that is useful to us. And I'm just going to write the equation of this line. So we've got a y squared there, so that means that this is going to become y squared 2615425.9 plus, this will be a minus 13234.8, and this is x. So that's what the equation would look like. So currently that is negative 0.937. So it hasn't really done that much, to be honest, if I can confess to you. I just want to make sure that that is the plot that we want. So setting list 1, list 3, yeah, that's, as you can see there, it hasn't done that much difference to change the, from a linear to or from a non-linear to a linear. So we're going to compare it if I square the x values instead. So what I'm going to do is I'm going to go and close that. I'm going to go to setting. Now x squared was in list 4, and so we want the y list to be list 2. The x list was in list 4, set. And what we're going to do is regression, X list is list 4. Y list is list 2. Press OK. Oh, look at that. Oh, wow, look at that R value. I wouldn't even want to round this up, but negative 0.999998. So in other words, -1, which is a perfect correlation. So we can write the equation of this one. This would be y equals 1559.998. I'm just going to do it in 3 decimal places for now. Minus 4.901 x squared is the equation there. And we can see what this looks like. Oh my goodness, look at that. That could not look any better than it possibly. Look, all of them are virtually on that line. So this is by far the best adjustment that we can make. Which is the stronger association? That's clearly this one here, because not only is it stronger than these, it's very much a straight line. Find the regression line of the stronger associated transform data in terms of the variable. So this is our worded equation. So we're going to write this was the height. And this is equal to 1559. Does it say how many decimal places? No, I'll just put 3 just for the lols. 4.901. And this time we need to write, this is time squared. Now the next thing here, it says, is that we need to use the transformed regression line to predict the height of the base jumper after 3.4 seconds. So this is where we need to substitute. Now when you're in an exam or a SAC, it's worthwhile actually showing the line of arithmetic in case you do something wrong or one of your previous values is incorrect, and so therefore you can get some consequential marking. So height is equal to 0.998 minus 4.901 times 3.4. Notice that I'm putting there in a bracket. That is because if you end up with a negative number and you don't put brackets in there, the calculator is a bit dumb and doesn't understand what you mean, because if you need to put a negative number in there, so the calculator understands that you mean negative 3.4 times negative 3.4. Otherwise, if you don't, it will think you mean negative times 3.4 squared, which is wrong. There's obviously no negative number here. I'm just telling you that for future purposes. That's why I put those brackets around there. 1503.342 meters.